Okay, last thing to know. So when you do check your answer, let's say I solve this problem right here. So I'm going to do 3 times x and 3 times 5. I should have done keep, change first, but in this case, let's see. 3 times x is 3x. 3 times negative 5 is negative 15. Does that equal 15? So then I'm going to remove a balance set. I'm going to get rid of negative 15, and then I'm going to get rid of negative 15 here. And 15 minus negative 15, a lot of students think that's going to equal 0, but if you're careful and you remember about keep, change, subtracting a negative equals adding a positive, and 15 plus 15 is equal to 30. The other side, negative 15 minus itself equals 0, and what I have left is 3x. So 3 times the number equals 30. I'm going to divide by 3 and divide by 3. That's the inverse operation, and I get x equals 10. 3x divided by 3 is x. 30 divided by 3 is 10. So I'm going to take my 10, and I'm going to plug it back into the equation. But I don't know if you guys noticed this, but it's the exact same except I took out the x and I replaced it with a 10. So now I'm going to go ahead and do that math. 10 minus 5 is 5. And then 3 times 5 is 15. And 15 does equal 15. This is true. So that means that x equals 10 is my answer. Some students get confused and think that this will mean 15 equals 15. But it actually, what the 15 equals 15 part means, they think, oh, that's my answer is 15. But really, what it means is the fact that these are the same confirms that your solution is actually x equals 10. Now, if you make a mistake in math, the great thing about this check is, let's say you make a mistake and you come up with the value of, where's my other purple? Let's go with this purple. I like this purple. Is that, yeah. Let's say you come up with, if you come up with x equals 2. So then if you do 2, you plug in the 2 for the x, and you do 2 minus 5, and that equals negative 3. And then you do negative 3 times 3, and you get negative 9. Now, it says the whole time that all of this is supposed to equal 15, but when you get to the end, you go, does negative 9 equal 15? No, it does not. So x cannot be 2, because if x is 2, then it's not equal to 15. So when this is not true, I know x is not equal to 15. Or sorry, x is not equal to 2. And that's how you check your answer. It comes in very handy when you're in a test and you go, I wonder if my answer is right. You can plug it back into the top and then go ahead and solve the problems with just the numbers, and then you'll find out if you're right or not. And that's